Here we are at the second of 4 sessions that we're going to do with Chapter 2. Remember, we're going through this rather quickly because this is primarily a review of your Algebra 1 studies. In this session, we're going to cover sections 4 and 5 about solving and using inequalities. The things we want to keep in mind here: determining if a number is a solution. This is fairly easy. We just plug it in and see if it works. Graphing the solution sets. There's a few things we have to remember there. One of them is, when do we use a solid dot and when do we use an open dot? We'll get into that in a few minutes. Just a little review. Solving inequalities using the addition property. Solving inequalities using the multiplication property. This is almost, not quite, but almost the same as what we did with equations. First off, we do our little review. How are we going to solve this? Well, we're going to use the addition property first, which says that as long as we add the same amount to both sides, we maintain the truth of this equation. So we get 3x equals 7. X equals, what are we using this time? We're using the multiplication property of inequality, which tells us that we can multiply both sides by the same thing and it will keep the equation true. So we're going to multiply by 1/3, which gives us 7/3. On this one, the first thing we would do really is combine like terms. So we'd have 6x minus 3 equals 7. That doesn't look like a 7. Equals 7. I'm going to use the addition property of equality, so I'm going to add 3 to both sides. Now I'm going to use the multiplication property of equality. And we know that that will simplify, and to get full credit, you want to go ahead and simplify that. You can leave it as an improper fraction. That's perfectly acceptable. In this one, I've got x that I'm solving for trapped inside parentheses. When this happens, we know what to do. We distribute. That'll give us 6x minus 12. And on the other side, we don't have any work to do. Now we can use the addition property of equality, which allows us to add 12 to both sides. So we get 6x equals 18. X is equal to 3. What did I use there? The multiplication property of equality. We're going to have to distribute in number 4 because our x is within these parentheses, so we've got to clear these parentheses. I end up with negative 6x. What am I going to get here? Thank you. Just wanted to know that you would handle that correctly. Now I'll subtract 10 from both sides. And I'll divide both sides by negative 6. I hope that's what you got. solving inequalities. So we'll get right into it now. We need to match the symbols to the words. Is less than and is less than or equal to. This is the one we use for is less than. And when we also have or equal to, we have an equal sign added to it. Is greater than, right here. Is greater than or equal to. So you see what the difference is there. It's the equal calls for at least part of an equals symbol, right? If A is less than or equal to -2, so let's plot where that would be. Where would our A be? A is less than or equal to -2. So we first of all have to find that boundary of -2, and we'll plot that. Is that going to be a solid dot or an open dot? Because there's an equal, it's going to include, this boundary is going to include that point, so we make it solid. Less than, so that tells me it goes this way. I'm going to change the color of the pen in order to make this a little easier to follow. For B is greater than -2, so we have the same boundary. Here it is. This time I'm just going to have an open circle because it's not also equal. It doesn't include -2. So here's my B. Doesn't include -2, but includes everything greater than. The question, of course, was, can A equal B? Is there any point where A is equal to B? Well, you might think -2, but when we look at it, at -2 we have A, but we don't have B. All this is for B is the mark of where we start from. It doesn't include -2. So the answer here is no. Let's try this one. I'm going to again change my colors to help us follow what's going on. You can use color pens yourself, colored pencils in your work. Our boundary is at -1, and it's going to be a solid dot because it has an equals. This time it's greater than, so we're going to go from that boundary to larger numbers. And then our B, our boundary is at 1, and it does not include 1, so it's an open dot. And it's everything greater than 1. Can A equal B for these two? Well, yes, it can. We can have, no, that's not going to work. Get that. Because we don't have any B here. But right here, from this point, not including 1, but everything greater than that, we have the situation in here where A equals B. Only here. It doesn't, it's not true for the rest of this, and let me mark it. For all the rest of this, A does not equal B. Okay. Determine whether the given number is a solution. Well, one way to do that is to simply plug the number in. If x were equal to 1, what would we have on this side? We'd have 8. And then you look at your statement and say, is that true? 8 is less than 9. So we'd have to say yes. Now in this one, if we say x is 2, we get 8 minus 2. Is 6 greater than 7? No, so not true there. How about this one? If x is equal to 0, oh, I love this. It's so quick and easy to do. This will zero out. This will zero out. 4 greater than or equal to 8? No. So 0 is not a solution to this inequality. Let's graph on the number line. This will be quick and easy for you to do. X is greater than -1, so we mark our boundary and we determine whether that boundary is an open dot or a solid dot based upon whether or not an equals is here. No equals, open dot. And this says greater than. How about this one? Here our boundary is at 0, open dot or closed. It's got the equals, so it's closed. And we're going to say greater than. So that's how you would graph that. We're going to use the addition property of inequality, which is exactly the same as the addition property of equality. In this case, we can add a -3 to both sides, leaving us with x on this side. Same symbol. We add a -3 over here. Where's our boundary? It's at -5. Is it open or closed? It's open. There is no equal. And it's going to be less than that. So when we go to graph it, it looks like this. The multiplication property of inequality. It is similar, but it has a difference to the multiplication property of equality. When you are multiplying an inequality by a negative, you must reverse the symbol. So let's see where that will show up. In this case, this first one, we're going to multiply both sides by 1/5. So this will become x is greater than 12 divided by 5. 12 divided by 5, to help us graph, it's actually better if we don't have an improper fraction. So one-time improper fractions don't help us much. This will be 2.4. Is that correct? 5 goes in twice, leaving us with 2/5, which is the same as 4/10. So we've got x is greater than 2.4. So we want to mark that boundary. It's right about here. And it's going to be an open dot because there's no equals. And it's greater than. So we've graphed it. How about this one? Here, we're going to multiply by a -1/5. When multiplying an inequality by a negative, you're going to reverse the symbol. So that's going to become x greater than. Okay, so I went from a less than to a greater than. I reversed the symbol. And here I'm multiplying this by a -1/5, which will give me 3. Where's my boundary? It's right here at negative 3. It's an open dot because equals isn't included. And it's going to be greater, all the larger numbers headed this way. Solve and graph this one. Here again, I'm going to be multiplying by a negative 1/3. So this will become x. I'm going to reverse the symbol. You agree? This time, my boundary at 2 is going to be solid, because we are including a 2. It could be equal to 2. It's either equal to 2 or it's less than 2. So it's going to graph like that. Now we're going to use both these properties of inequality. If negative x is less than 10, can x be equal to 20? So negative x less than 10. Which is saying negative 20 is less than 10. So our answer here is yes, that is true. If negative x plus 8 is less than or equal to 2, can x be a negative 6? Well, let's try it. So we've got a negative x plus 8 less than or equal to 2. And we're saying our x is a negative 6. What will this become? This will become a positive 6 plus 8, or 14. Is that less than or equal to 2? No. If A is less than B, can 10A be less than 10B? Well, you know, we can, to figure this one out, we can actually use the multiplication property of an inequality. We'll just multiply both sides by a positive 1/10, and we'll get A is less than B. So this would be true. Yes. If A is less than B, if you multiply both sides by 10, that will also be true. If A is less than B, can you say negative 10 is less than negative 10A less than negative 10B? Well, let's try that one. For this, we're going to multiply both sides by a negative 1/10. And when we multiply an inequality by a negative, we reverse the symbol. So we'll end up with A greater than B. So, no, that's not going to work. Use the properties of an inequality together. Well, back here I actually didn't, but here I will. All right, so, I've got 3 here, and I got a 3x here. I want to get all my x's on one side, just like if I were solving an equation. Let's start out by adding a negative 3 to both sides. So we'll have negative 5x is less than 3x plus 4. I love the addition property because it is exactly the same as the addition property of an equation. Now, when we get to the multiplication property of an inequality, it is different. It's only different when we're talking about a negative, but we are talking about a negative here. I'm going to multiply both sides by negative 1/5. X is less than negative 3/5 x. Oh, I don't want to do that yet. No, take that back. What did I forget to do? I need to get all my x's on one side. So I'm not going to use this property yet. I'm still going to work with the addition property. I'm going to add a negative 3x to both sides. That'll give me negative 8x is less than 4. Now I can use my multiplication. And I'm going to remember to reverse the symbol because I'm going to multiply by negative 1/8. That'll give me x greater than negative 1/8 times this will give me, and when I graph this, negative 1/2 will take me right here. Open or closed? That's right, it's open, there's no equal. And it's going to be greater than, so I'm going to go for all the numbers larger than that. Using, remember, every time we see using, it's going to talk about a word problem, and we're going to use this 3-step process. Understand what's being asked of us, figure out what you're going to do, then do it, and finally, does it make sense? Five minutes for just doing a quick review. Write an equation. We're going to get into inequalities in just a minute, but we're going to go back to something that's more familiar to us. A number n plus 5 is 7. Now we know is always stands for an equals. So n plus 5 equals 7. We're not going to solve these today. We're just going to write out the equation. For the most part, when you're doing word problems, it's coming up with your statement that is most difficult, your algebraic statement. The sum of, so we're going to be adding something here, the sum of twice the number x, so 2 times x, and here's where we get into the sum, plus 2 is, there's our equals, 3 times x. The sum of 20% of b, remember we always, when we're talking percent, we are going to convert that into decimal, and 0.2 would represent 20%. The sum of 20% of b and 1 equals b. We could solve any of these, but the point here is to just be able to read and convert what we read in words into an algebraic, in this case, equation. Twice c, 2 times c, is, remember when you see this than, please start with the c, and we're going to say 5 less, there. Okay. If x is not more than 10, if x is not more than 10, so if we were looking at a number line, and we've got 10 right there, Not more than means it could be equal to, right? But it cannot be more than 10. So what do we know? If we did a little graph of it, it's there. Could or is x equal 10 true? Yes, because 10 is not more than 10. Is x less than 10 true? Is x greater than 10 true? That's the point. It cannot be greater than 10. Let's try another one. If y is at least 15. So let's try a little number line. You're going to find out I love to do things graphically. So here's that boundary, 15. We're saying y is at least 15. So it could be 15, right? At least 15, it is 15 or more. So y could be 15, we know that. Y could not be less. We said it was at least 15. And y certainly could be greater. Yes. Write the given inequality. So in this case, it'll be y at least 15 is written this way. Greater than or equal to 15. And for this one, x is not more than 10. X is less than or equal to 10. If you find yourself getting confused by words, try drawing a little number line to help you out. To set the record in a local triathlon, you must have a total time under 10 hours. Okay, total is 10 or less. Maybe I should write that down. Total is less than 10. Not equal to, right? It said under 10 hours. Your running time was 3.2 and your bicycling time was 5.4. What time is needed for swimming? Well, let's say your swim time is what we're looking for. We're going to call that x. We know that your running time, 3.2, plus your bicycling time, 5.4, plus your swim time, which we don't know, and that's the thing we're looking for, x, it all added together has to be less than 10. So we have our algebraic statement here. We translated it from English into math. Now we need to use our knowledge of algebra. These are common terms. We can add them together. We get 8.6 plus x is less than 10. Now the addition property of inequality is exactly the same as the addition property of equality. I can add a negative 8.6, that's a point, to both sides, a negative 8.6. So I'll have x has to be less than, when I subtract 8.6 from this, 1.4. If it equals 1.4, my total time will be 10 hours, and I have to have under 10 hours. Here's another. In this problem, 2 medical insurance plans are available. Plan A pays 80% of all medical bills after the first 100. So A pays how much? Oops, let's go back up a little bit. A pays. We're going to look at what A pays. And B pays. We'll look at how much B pays. I have a little bit of problem apparently making a semicolon here. B pays. There. After I pay the first 100, Plan A will pay 80%. Remember, we always convert percent into decimal. It'll pay 80% of all my medical bills. Well, so medical bills minus 100, because it's not going to pay that. We're going to let M equal the dollar amount of all my medical bills. And it's not going to pay the 80% of that first 100, so I better subtract that out of here. And B is going to pay 60% of my medical bills after I have paid the first 10. The question is, for what range of bills is A the better plan? Well, I better find the boundary between these two plans. Where does it kick over from one being better to the other one being better? So I'm going to use an equation to find my boundary point. The equation I'm going to use is the payment. Where does the payment from A actually equal the payment from B? So I'm going to, as I write this out, I'm going to do my distribution. So we'll have 0.8 M minus 80. See, I distributed that 0.8. And 0.6 M minus 6. So where is the dollar amount where these two plans are exactly equal? I'm going to add 80 to both sides. I'll have 0.8 M equals 0.6 M plus 74. Now I'm going to subtract 0.6 M from both sides. Or another way to think of it is I'm going to add a negative 0.6, and I'll have 0.2 M equals 74. So the boundary is going to be at M equals, let's see, 74 times 5. I'm multiplying both sides times 5. Do you see why? If I multiply this times 5, it will become 1, which is what I want. Whatever I do to one side, I must do to the other. So this will give me 20. 370. 370. So that's the point where one plan becomes better than the other. We have to figure out, if I have very few bills, which plan is going to be the better plan for me? Well, if I have very few bills, I think this would be best, wouldn't it? But if I have a lot of bills, Plan A is going to be the better plan. So for what range of bills is A the better plan? For not equal to $370, but anything greater than $370. Now, if I weren't too sure about my logic, I could test it. I could take, for example, $400 and say, okay, what will Plan A pay me if I have $400 of medical bills? What will Plan B pay me if I have $400 of medical bills? I actually have worked this one out in advance. So let's see. Plan A pays more of the medical bills once the total medical bills exceed 370. And here we have it written as an inequality. It does not include the equals because at that point A is not the better plan. It's simply the same as B. Whoop. So we are done for today. See you back in class.